Hey guys, so last time we went ahead and talked about the interquartile range as a measure of spread for any skewed distributions, right? And we were also able to use the interquartile range to determine any outliers within the data sets. So now we're going to kind of bring everything home, the 5-number summary, outliers, and everything like that, and come up with a way of creating this box plot. The box plot summary basically tells us a lot of information about the distribution, so let's go ahead and dive on in. So all you need for the box plot is the 5-number summary and any outliers in the data. And so we've practiced determining the 5-number summary and also determining which of the data observations are outliers. Now, one kind of confusing concept. Here we go. So the fences, you see these lower and upper fences, and I'm referring to these two here. So those two fences, they aren't actually the maximum and minimum. The minimum observation is going to be this one. So here's our min. But where's our maximum? Our maximum is actually the highest data point, right? So it's going to be this one. That's our maximum data point. But why isn't it part of the box plot, right? Why is it totally separate? Because, now let's go ahead and kind of fill in some of the rest of the data. We have Q1, right? Our first quarter. The second quarter was what? Median, right? It's the 50 percentile mark. Next is 75 percentile, which is Q3, right? And now, before we touch that last one, what's the distance between Q1 and Q3? So that difference between Q1 and Q3 is what we just talked about recently, the interquartile range, right? So here is the interquartile range, abbreviated IQR, right? So just from Q1 to Q3. Now what do we do in order to determine if there are outliers? We didn't just use interquartile range, right? We use 1.5 times that above Q3 and also below Q1 in order to determine this kind of limit or interval in which observations aren't outliers. Anything outside of that, observations are going to be outliers. So here we have 1.5 times the interquartile range. Here's 1.5 times the interquartile range. And essentially, anything above the upper fence, aka this one here, the upper limit. And I say fence and limit, they're basically referring to the same thing, right? It's kind of like this cutoff point is what we're essentially referring to. And then we also have this fence or limit or cutoff point on the left side too. So anything within those two cutoffs is not an outlier. Anything outside of that are outliers. So what we see happening is that the maximum data point and actually 3 more points are all outliers. So they're not going to be part of our direct box plot summary. They're going to kind of be little points or stars outside of that. But now, why does it only stop at this point here? The reason for that is because you see, for example, the lower one, you see the minimum is right there, right? We're not going to actually draw the fence all the way to the edge where it would be considered an outlier because we don't have any data points there, right? So there's not going to be any drawing for that because there isn't any data that's actually past that minimum point. So we stop our fence at the maximum that we need to stop it at, right? We're not going to continue past the minimum because that's where we stop. Now on the right side, our fence stops not at the maximum. Why? Because the 1.5 times interquartile range is at a certain point, and there's only a maximum data point that hits within inside. So we see happening on the right side is that we have this interquartile range limit, but we only mark the maximum point that falls within that limit. Why? Because there's no data between that number and that upper limit for our outliers. So there's no need to go ahead and draw anything there. So we stop it at the maximum point within our 1.5 times IQR limit, right? Above and below. And anything outside of that, we're represented by dots, stars, little boxes, however you want to represent that. So this is actually the maximum point within 1.5 IQR. Does that make sense? And so you don't ever draw anything past, your fence never goes anything past the maximum minimum points within the interquartile range. Now there could be maximum and minimums outside of that, but those would be outliers. So let's go ahead and just represent that here. So all these four little guys are all outliers. They're weird. Poor little guys. Okay, so let's go ahead and construct our own box plot for the following data set. So we see that a bunch of different numbers. What do we start with? What do we have to do in order to get the median and quartiles and interquartile range and things like that? The first step is to get the data ordered, right? So let's go ahead and put it in order. So we have 0, 30, 32, 42, oh I'm sorry, 34, 42, 52, 61, and 102. Does that make sense? How did we find the median? The median, we always found it by, you can either just cross off left to right until you get to the midpoint, but a more just mathematical and just simple way of doing it is n plus 1 over 2. So it's observation n plus 1 over 2. What's our n? Our n is the sample size. Right, good job. So our sample size in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. Is that 8? 3, 6, yeah. So we have a total of 8, so 8 plus 1 over 2. And if you plug this into your calculators, make sure you put a parenthesis so the calculator knows that 8 plus 1, aka 9, divided by 2. So 4.5 observation. That's going to be our median. So how do we determine that? We just go ahead and look at our data, and we see that, sorry about that, we see that 1, 2, 3, 4, 5. So we see that our midpoint or our median lies somewhere in between these two. What did we do in order to get the median if it fell in between two numbers? We got the average, right? So the median is 34 plus 42 over 2. So 34 plus 42 over 2 gives us 38. So our median is 38. Awesome job. So that's step 1, right? So we got 1 out of our 5-number summary, right? Because that's our first step, is to get the 5-number summary. So, and let's actually go ahead and write that down so we don't forget. So step 1 is the 5-number summary. So I'm going to say 5 numbers. Summary. And then step 2, we need to also determine if there are any extreme values, aka outliers, right? So are there outliers? Question. So we got our median. What else do we need to get for our 5-number summary? For 5-number summary, we need min Q1, median Q3, and maximum, right? So let's go ahead and just keep going with our median mode and find Q1. So Q1, our data is split in half right here, right? And so our data being split in half right there, we have 4 observations on the left, 4 observations on the right. And what we end up getting is that our median is somewhere in between here, and our Q3 is going to be somewhere in between those two numbers, right? So if it's in between 2, what do? We do the same thing we did for the median, right? It's in between 2, let's get an average. So Q1 is 30 plus 32 over 2, and Q3 is 52 plus 61 over 2. So Q1 ends up giving us 31, and Q3 is 56.5. Don't worry, I didn't do that in my head. Not that smart. So we got our Q1, Q3, our median. The other two are the minimum and max, right? So I'm just going to write these in the corner so we can save some space. So our minimum is equal to what? The lowest number, right? What's our lowest number in our data set? It's going to be 0. Good job. And our highest is 102. I know you guys were thinking. It's okay. So our highest is 102. We got our 5-number summary, check. Beast, right? So we got that covered. What's next? Outliers. How do we get an outlier? Our outlier, we're gonna need the interquartile range, right? How do we find that? Nice. So the interquartile range is actually Q3 minus Q1, right? So Q3 was 56.5 minus 31, and that gives us 25.5. If you don't believe me, check your calculators. So that's our interquartile range. What did we do with that in order to determine if there were any outliers? We multiplied it by 1.5. Good job. So it's 1.5 times the interquartile range. So it's 1.5 times 25.5. And that gives us I don't know. 38. And that gives us 38.25. So, what do we do now that we have this 1.5 times IQR? Basically, we know extreme points, kind of referring back up to here if we need to. So referring back up to our box plot, we use the 1.5 interquartile range to go from, here's our interquartile range, right? Q3 plus 1.5 times the interquartile range gives us where our maximum is in terms of what is considered not extreme versus extreme. And then also on the other side, we have, here's our interquartile range, and then here's 1.5 times that, right? And so anything out here and down is also an outlier. So let's go ahead and determine what are those two intervals in which our observations are not outliers so that we can see anything that falls outside of that. So our upper fence, or our upper limit, is going to be equal to Q3 plus 1.5 times IQR. So Q3 was 56.5 plus 38.25. So we end up getting 94.75. Right? And then our lower limit, let me go ahead and start highlighting because we're having a lot of different numbers and stuff, and so let's not get confused. So here's our 5-number summary. Right? And then let's also get our limits. So 94.75. Let's get our second one. Our second one is the lower quartile minus 1.5 times IQR, or the interquartile range. So we get 31 minus 38.25. So we actually end up with a negative, which is fine. It's not a problem. So now, question for you guys. Are there any outliers? So looking at that data set, our lowest one was 0, right? So that falls within our 1.5 interquartile range limit, right? Because our lower limit was negative 7.25. 0 is in there, right? But now what about the upper end? The upper end, our maximum was 94.75. Do we have an observation outside of that? Yes, we do. So our observation outside of that is actually 102. So 102 is going to serve as our outlier. Everything else falls in between. So let's just go ahead and start drawing. So I'm going to draw a little number line. What's our first number, starting from left to right? So our first number, and actually let me remove myself so that we can get a full view of this. So our first number is going to be which one? The minimum, right? So we have our minimum, which is 0. Good job. Right? What's our next number? So if you want, you can refer to these numbers up here. Right? So these are just here to kind of help you out if you need them. So our first number was the minimum, and then our second number should be Q1. What was our Q1? Q1 was 31. What's next? Next in line is our median, which is 38. So I'm going to kind of draw this to scale. Next is Q3, which is 56.5. Right? And now, our maximum is 102, right? However, 102 is going to be considered an outlier. So where does our fence stop? So our fence is going to stop so this is actually 94.75, right? Because that's where our upper limit is. That's where anything past that, there's going to be an outlier. But what's the highest number that falls within that? That's where we're going to be stopping. So if 94.75, let me actually move this over just a little bit. So 94.75, again, is kind of like that upper limit to where we have an outlier. And our outlier is that 102. So the highest one that falls within that is actually 61. Does that make sense? So 61 is our highest that falls within that outlier kind of limit. So let's go ahead and start drawing. So here's our lower one, keeps going, we hit our Q1, hit our median, hit our Q3. And then the last one that it reaches is 61, and then anything past that, we just represent it by a little dot. Does that make sense? So essentially, we have our minimum, Q1, median, Q3, and then our maximum. But again, the minimum and maximum are the minimum and maximum that fall within the not outlier range. Anything outside of that, we have to represent it by little dots. So it's a quick run through of the box plots. And now let's talk about what this all actually means. So just looking at the box plot, you can tell symmetry or skewness. Sorry about the space. So you can tell symmetry or skewness by looking at the distances from the minimum in Q1, so basically the lower end, to the median, or the midpoint, and also the max in Q3, aka the higher end, and the median. So the further Q1 and the minimum are from the median, the data is most likely skewed to the, what do you guys think? So the further Q1 and Q3 are from the median, it's actually likely skewed to the further Q1 and minimum are from the median, it's going to be skewed to the left. Why? Because essentially, what we'd end up having is, say this is our minimum, right? This is our Q1. Let's say we have something like that. If we kind of draw a distribution relative to that, what happens is kind of looks like a distribution that's skewed to the left. Because essentially, 50% of our data lies between Q3 and the maximum. Put myself in here. So 50% of our data lies between Q3 and the maximum, right? I'm sorry, median and Q3. So the median in Q3 holds 25% of the data, and it's so small, so that means it's very concentrated. There's a lot of observations that fall between that little range. And then the bigger range we have from the median all the way down to Q1. So here the data is a lot more spread out. So it kind of looks like it's spread out, and then it gets really concentrated on the right side. So it's skewed to the left because our tails on the left and also our outliers are on the left-hand side, right? So now what about for the Q3 and the maximum R? So it's basically the opposite direction, right? We're going to have here is really short. And then it's kind of spread out on the right side. So our data is super concentrated on the left, and then it kind of goes and spreads out a lot more on the right-hand side. So our outliers are our extreme values, and also half of our data is essentially spread out over a longer distance. So it's concentrated, and then it kind of spreads out. And so that we refer to as skew to the right. Cool, so how do we apply this information? So, quick example, looking at the box plot from example 1, what can be said about that distribution? So again, I'm just referring to the box plot right up here. So the box plot that we drew earlier in example 1, let me scroll up just a little bit. So that box plot, what do we see happening in terms of distances? So there's a small gap, right? There's a small gap between Q1 and the median, and there's a larger gap between Q3 and the median. And there's also an outlier, right? And so that's also a nice little hint. If there are outliers, it's really a great way of telling you that it's probably skewed where the outlier is. So here our situation, we have a lot of data concentrated on the left. So a lot of data on the left, and then it's spread out, and there's actually an outlier all the way on the right-hand side. So we say that this box plot is skewed to the right. Now let's do one more quick example. So here's just a random box plot. So looking at this box plot below, what can be said about this distribution? So again, let's use that kind of same general idea. We have a lot of data kind of in between this little chunk, right? So here's 50% of our data. And then here is the other 50%. So what that translates into is a distribution that looks kind of like this. And this distribution is what? Skew to the left or skew to the right? Skew to the right, good job. And another hint too, outliers, they're going to be the ones that tell you where the skew is going to be. Are they on the right or on the left? Outliers here are on the right, so they kind of stretch our distribution all the way on the right-hand side. And that's about it, guys. So we basically went over a lot of information, interquartile range, as a measure of spread, medians, quartiles, how all this data breaks down, what we can do with that. We can construct these box plots, and now our box plots can also tell us information about the distribution itself. Is it skewed to the left? Is it maybe symmetric? Skewed to the right? Are there outliers and things like that? So thank you guys for joining. Hopefully we'll see you guys for our next video. Thank you very much.